Here we go. Our objective for today, I can add and subtract rational expressions. Read together, 1, 2, 3. I can add and subtract rational expressions. We don't need a Fourier model since we already know that we're still in the same chapter on rational expressions. So, but we started with multiplication and division. Now we're going into addition and subtraction. So check this out. Like I said, we don't need the Fourier. Here it shows the rational expressions are fractions with polynomials. These are not because they're equations. This one's not a fraction. Therefore, steps, write these down, please. We got 5 basic steps we're going to follow today. Number 1, identify common denominator. Step 2, add or subtract the numerators by combining like terms. Look at number 3. I changed the color of that one. That's for fractions that don't have a common denominator. If they don't, you need to find the, you need to, if you see that they have uncommon denominator, you simplify each fraction first, and then you continue by factoring completely, finding the common denominator, and then from there, factoring the numerator and denominator and simplifying by dividing out giant ones. Copy that, please. Now, the first steps are similar. Check this out. Identify the common denominator. From there, you add or subtract the numerators by combining like terms. From there, you factor completely, and then you simplify. However, you do the first 2 steps, but if you don't, let's say if you cannot identify a common denominator, that means you have something with uncommon denominators. That means you need to simplify each fraction, then you follow the rest of the steps. Okay? So with that said, copy this down. Example 1A. 1A. It says, example 1A, add, simplify your answer, 2x over x to the 4th plus 4x over x to the 4th. Copy that. Okay, here we go. So, pens down, eyes up here. I'm going to go over this one step by step to make sure you got this. And then from there, we'll do another one together. Here we go. Pens down, eyes up here. Writing utensils down. Okay, here we go. So, look at the fractions. Right now, what we're going to do, let me show you first with numbers. When we had fractions just with numbers, we had, let's say, 2/5 plus 4/5. What would we do? Identify the common denominator. We write it. From there, we add the numerator, so that's 6, and then we simplify. Is that correct? That's exactly what we're doing today, but now we're doing rational expressions when it involves polynomials. So check this out. Do we have a common denominator here? Yes, it's x to the 4th. I just wrote it again, right? For one fraction. Step 2, you're just paying attention. You're adding or subtracting the numerators by combining like terms. So what I'm going to do, I'm going to draw a heart. There it is. So we got 2x plus 4x, that is 6x. Step 3, I'm going to skip because that one's for when we don't have common denominators. You're just paying attention. From there, we're going to factor completely. Check this out. This becomes 2 times 3 times x. And this one is x times x times x times x. Do you see a giant 1? Yeah, right here. And what do we have left? 6 over x cubed. Copy that, please. And we're done. All right, here we go. Example 1b. Copy this down. 1b. It says, add and simplify your answer. M squared plus 2m over m plus 4 plus 3m plus 4 over m plus 4. We're going to do this one together. Ready? Here we go. Step 1. Identify the common denominator. What's our common denominator? So we write that under 1 bar, m plus 4. So it becomes one fraction because we have the same denominator. Step 2, we're going to add or subtract the numerator by combining like terms. That means we're going to draw our heart right here. Oh, there it is. So let's find out. Is m squared the same as any other? No, I just write it, m squared. Is 2m like any other term? Yes, like 3, so that gives us what? 5m. And then I just bring down the plus 4. Are we there so far? So did you guys notice I combined what I could from like terms? All right. From there, step 3 I skipped. From the notes, it was in case we had uncommon denominators, and we go to step 4, factor completely. Therefore, this looks like a trinomial, so I open 2 parentheses. The m squared becomes m and m. Get it? M and m. And then we're going to use the Power Rangers right here. What goes on top? 4, and then the 5. Think about it. What factors of 4 add up to 5? 1 and 4. So this is m plus 1, m plus 4. Focus, please. We're still not done. What's GCF on the denominator? No, GCF. 1. And we're left with m plus 4. Do you see the giant 1? Yes, right here. So we're left with m plus 1 over 1, which is m plus 1.
So you didn't have to write down that one.
Yeah, I want you to write the over 1 because I just want to make sure that you're following through with all your factors. Okay? Everybody got it? Okay? Copy that. I'll give you about 5 seconds. It should be, because we're doing this together, right? Just to finalize it. Okay, example 1C. Let's do the next one. And see if you can do the next one by yourself. Here you go. Example 1C. There it goes. Example 1C. We got 3k minus 18 over k squared minus 16 plus 6 over k squared minus 16. By looking at it, we do have a common denominator. However, tell your neighbor what is so particular about that denominator. That's called what? Difference of squares. That's a good hint, okay? Copy that and solve it. See how you do. Go. Okay, here we go. So step 1, identify the common denominator. Common denominator here is k squared minus 16. Is that correct? Step 2, add or subtract the numerators by combining like terms. I'm going to draw my heart. K, 3k, are there any other in the numerator? No, 3k. But then I have negative 18 plus 6, that gives me negative 12. Hands if you got up to right there. Okay, good. From there, step 4, factor completely. Is there a GCF in the numerator? 3, and we're left with k minus 4. And earlier we had a hint from your neighbor. They said this is difference of squares, so you take the square root of the first, that's k. Square root of the last, that's 4. It's a subtraction, yes, difference. So this is k minus 4, k plus 4. Is that correct? And your giant 1 is right there. So we're left with 3 over k plus 4. Hands if you got that by yourself. Okay, good. Let's do another one. Here we go. How are we doing? All right. Let's do another one. Yeah, it's a little rigorous. It's not just something so simple, but it just requires more steps. Okay. Here we go. Copy this one, please. Example 1D. This is 1D. 1D. A1D. There it is. What? That's an IT. No? Okay, fine. 1D. All right. 3y squared over y plus 1 plus 3y over y plus 1. Do that one by yourself. Hopefully by now you should be able to finish it off. Go. Now I'll get somebody to help me with this one. Okay, let me get the randomizer and get somebody to... before I pick somebody, show your neighbor, see if they got something similar to yours. Here we go. About, how weird. All right, here we go. Victoria, step 1. Okay, step 1, you said what? Y plus 1, which means identify the common denominator. Yes. Pass it to someone, please. Step 2, Heather. The heart. We're going to add the numerators by combining like terms. Can we combine anything? This one has an exponent, this one doesn't, so we just write them, right? This is 3y squared plus 3y. So far so good? Okay. Step 4, factor completely. Yeah, pass it on. Okay, factor completely. How can we factor this one? Do you see a G? What is the first step when you hear the word factor? GCF. Is there a GCF there? 3. What else? Y. That is correct. So then what's left? Y plus 1. That is correct. What's GCF down here? 1. And we're left with Y plus 1. Do you see the giant 1? Yes, which is here. So what do we have left? 3y over 1, which is 3y. Hands if you got that by yourself. Okay. All right. So we're done with addition. Let's move on to subtraction. Here we go. Copy this one. Oh, sorry. Copy that one. Example number 2. Copy the instruction. Subtract. Simplify your answer. 6y minus 6 over y squared plus 4y minus 12 minus, this is a minus right here. I'm going to make it a little bit thick so you guys see it. There it is. Y plus 4 over y squared plus 4y minus 12. Okay, we're going to do this one together, but I'm going to ask you to stop somewhere in between so I can explain something really quick. So, let's see. Step 1, everyone. Identify the common denominator. What's my common denominator? Y squared plus 4y minus 12. Okay, so far so good? Step 2, add or subtract the numerator. So I'm going to draw my heart, let's see, around here with a minus and around here. At this point, I'm going to ask you to stop. Put your pens, pencils down, eyes up here. Check this out. This is what's different from addition to subtraction. Pay attention, please. Here's a negative. This negative is going to change these two to their opposite signs. So this becomes a negative and this one a negative. Why is that? Everybody look up. Because this is kind of like saying negative 1 times y plus 4. And what do we do there? You distribute. You guys see that? That's exactly the same that we have here. Negative 1 y plus 4. And you distribute. That's why we end up with what? Negative y minus 4. Are we there so far? At that point, once we distribute, now we can combine like terms. So let's see. 6y, and then we have minus 1y. What does that give us? 5y. Negative 6 and negative 4, that gives us negative 10. Copy that, please. So the next step is to factor completely. What is my GCF for this one? For the numerator. 5. I'm going to write it here, 5. And we're left with y minus 2. Are we there so far? This one. Is there a GCF for the denominator? No. I open 2 parentheses. The first one is y times y. Power Rangers. Factors of 12. 1 times 12. 2 times 6. 3 times 4. Which one of those add, subtract to give us 4? 2 and 6. And this one says that the biggest is a positive, so this is a negative. Y minus 2. Y plus 6. Do you see the giant 1? You guys see it? Yeah, right here. So we're left with, oh, that's an ugly 5. 5 over y plus 6. So what's the only difference between addition and subtraction? That for subtraction, this negative sign is going to change the signs of whatever's on the numerator on the right side. Are we there? Okay, copy this one. Copy this. Example 2A, it says, subtract. We got 5a plus 2 over x squared minus 4 minus 2a minus 4 over a squared minus 4. What do you guys notice the denominator is? I know, but what is that called? Difference of squares. So let's get started. Let's identify our common denominator. Our common denominator is a squared minus 4. Step 2, add or subtract the numerator. So I'm going to draw my heart. Aww. Combine like terms. But before I start combining, who notices that this is a negative? Therefore, the 2a changes to what? Negative 2a, and the negative 4 changes to positive 4. So let's see. 5a minus 2a, that gives us 3a. 2 plus 4, that is 6. Are we there so far? Okay. Next, GCF here. 3, and we're left with a plus 2. What did we say this was? Difference of squares. Square root of the first, square root of the last. So this is a plus 2, a minus 2. Do you guys see the giant 1? Yeah, right here. So we're left with 3 over a minus 2. That's the answer. That's the sum of those two fractions. Be nice. How we doing? Okay, let's do another one. Example 2b. Copy this one. 2b. Give me a second. Okay. Some of you already went ahead and you're almost done. Okay, let's see. So, first of all, common denominator is what? B squared plus 3b minus 4. That is correct. Next, we're going to add or subtract the numerator by combining like terms. So I'm going to draw my heart like this. Ah, there it is. But this negative is going to change negative 2b into what? Positive, and the positive 2 into a negative. So let's see. 2b plus 2b, that's 4b. 14 minus 2, that's positive 12. Hands if you did up to right there. Okay? GCF is 4, and we're left with b plus 3. Is that correct? Okay, let's factor this one. B and B, Power Rangers, negative 4 and 3. What factors of 4? 1 times 4, but they need to add to positive 3, negative 1 and 4, so the B plus 4, B minus 1. Is there any giant 1s? If we look up, can we cancel any giant 1s? No, so we're done. Which one? No, that's it. No. We only do the 2 times 2 when there's no addition. It's only multiplication. Here there's addition, so we don't break that down. Okay, so that's adding and subtracting using common denominators. But what happens when we don't have common denominators? Before I get to that, everybody look up. The homework's going to give you something like this. Find the LCM. We did one of these in the warm-up. And we've been doing some of these in the past, especially those that watched the video that I asked you to watch. Here it goes. So, copy this one, example 3A. It says find the LCM of the given expression. So, 12x squared y. I'm going to break this down to prime factors. So let's see. The 12 becomes what? 2 times 6, and this is 2 times 3. So therefore, 2 times 2 times 3. This one is x, x, and y. This one, 3 times 3. So therefore, this is 3 times 3, x, y, y, y. Get our Venn diagram. What do they have in common? The greatest common factor. 1, 3, okay. What else? 1x and 1y. 1, 3, 1x, and 1y. So therefore, GCF is 3xy. So that's GCF. But are they asking us for GCF? No, they're asking us for the LCM. So let's see. What's left for this side? 2 times 2, which is 4x. Right? You see this x right there? What's left on this side? 3y squared. So to find our LCM, all I have to do is multiply everything from left to right that way. LCM. So let's see. What is 4 times 3? Times 3, 36. What is x times x? X squared. What is y times y squared? Y to the third. That's our LCM. Yeah, it's like the lowest common denominator, but this is lowest common multiple. But guess what? We're going to need this for this next section that don't have the common denominator. Right. Here we go. So with that said, copy this one. Example 4A. Yeah.
Write down every common denominator with like 1 something.
So, example 4A says, add or subtract, simplify your answer. We got 2n over 5n cubed plus 4n over 2n squared. Okay, pens down, eyes up here. I'm going to walk you through this one. Here we go. All right. Focus, please. First of all, step 1, identify common denominator. Oops, it doesn't have it. So for this one, we go to step 3 from your notes. Step 3 says, simplify each fraction. So right now I'm going to focus on the first fraction, and I'm going to simplify it as much as I can. So check this out. I'm going to zoom in so you guys can see it. Here it goes. I'm going to focus on the first fraction. This one. Can I factor any more the numerator? No. How about the denominator? Yes. 5n, n, n. So, are there any giant ones here? 1n and 1n. What do we have left? 2, 5, n, n. Are we there so far? Plus. I'm looking at this fraction. I can't simplify anymore, so look at this fraction. Can I factor this one? Yes. 2 times 2 times n. So no longer use this one. How about this one? 2 times n times n. Do you see any giant ones? Yes, a 2 and an n. So I'm left with 2 over n. Are we there so far? So now check this out. We still can't do anything with these because we don't have a common denominator. So let me ask you the question. What does this fraction need that this one has in order to make it common? Times 5n. And whatever we do to the denominator, we do to the numerator. This becomes, now we write one fraction. What's our common denominator? 5n, n. And then what do we have? What is 5n times 2? 10n plus 2. What's GCF now? GCF is 2. We're left with 5n plus 1. And down here we have 5n squared. Do we have any giant ones? No. And that's our sum. Copy that, please.
But what if it was a front though?
As long as there's no addition, you can factor out or subtract. Okay, here we go. Copy this next one down, please. Example 4B. Copy this one. It says 2 over 5 minus w minus 5 over w minus 5. Okay, let's do this one together. Do we have a common denominator? We don't know yet because this one is not in standard form. So to write this in standard form, you need to write what? Negative w plus 5. Does that look like this? Not yet. What's GCF here? negative 1, so we're left with W minus 5. So this denominator became this. So now check this out. What does this denominator need that this one has? What? Look at it. What does this denominator need that this one has? Negative 1. That means we need to multiply this times negative 1. So I'm going to rewrite this now as one fraction. Check this out. My common denominator is negative 1 times W minus 5. All right, so what do we have there? We got 2. So at this point, I'm going to go ahead and add this and that, combine like terms. But this becomes what? Negative 5, right? So what is 2 minus 5? But this one has a negative here, which means this changes into what? Positive. So what is 2 plus 5? 7. Is there any giant ones right there? No, so we're done. How we doing? Yes? Okay. And pretty much that's it. All you have to do, make sure when you have uncommon denominators, simplify each fraction as much as you can, and find a common denominator by multiplying for whatever it needs, right? All right, homework for tonight.
Have a good day.
Page 6 what? 663.
1 through 3 odds.
1 through 31 odds. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.